Good morning. This recording is for Pre-Algebra, Chapter 7, Lesson 2, Solving Multi-Step Equations. There are several types of problems that use this whole multi-step solving equations business. Most of them are going to be word problems. Some of them are going to be what we can call consecutive integer problems. And then, of course, you're going to have your regular old math problems. All right, so what you need to know about multiple step equations that's different from lesson 1 of chapter 7 is that you do need to combine some like terms before you solve for an unknown. Remember, you can add and subtract like terms, and they must have the same variable for you to add and subtract them. Also, remember that there's an invisible 1 in front of all letters, unless it's got a different number in front of a letter. But regardless, that number that's always in front of the letters is called the coefficient. It's either a 1 if it's invisible or any other number that happens to be there. Okay, so here's a word problem. One basketball team defeats another by 13 points. The total number of points scored by both teams was 171. Solve the equation p plus p minus 13 equals 171 to find the number of p points scored by the winning team. So, remember that there is a 1 in front of both of those p's, which means if we're going to combine like terms, it's going to be 2p, because 1p plus 1p is 2p. Then, to solve for p, we're going to take care of low priority first, high priority second. And remember from last video, low priority stuff is addition and subtraction, higher priority is multiplication and division. So let's go ahead and set up the problem, and we're going to make our t, and we're going to subtract 13 on both sides, which means on the left side, the negative 13 and minus 13 and the plus 13 annihilate each other, and we're left with 2p equals 184. Now we're going to divide by 2 on both sides, because the opposite of multiplying by 2 is dividing by 2. The multiply by 2 and the divide by 2 annihilate each other, giving me p equals 92, because 184 divided by 2 is 92. And again, we can check it by plugging 92 in wherever we saw p in the first problem. And I added the parentheses. They're not necessarily necessary, but they would be there if they're there. Because again, we are going to check using PEMDAS. Please excuse my dear Aunt Sally, also known as taking care of parentheses exponents, addition, multiplication, division, and then addition, subtraction. All right, and we do that from left to right if they ever have reoccurring. So I'm going to take care of the parentheses. 92 minus 13 is 79. 92 plus 79 is 171, which means it works. Yay. Okay, so I'll go back for a second in case you need it, because I move on a little too quickly. Okay, moving on. So when you count by ones, you're counting consecutive integers. So 1 plus 1 to 2 is a plus 1. 2 to 3 is a plus 1. 3 to 4 is a plus 1, 4 to 5 is a plus 1, 5 to 6 is a plus 1. Those are what we call consecutive integers. They go in order from least to smallest, and you're counting by ones. All right, so that's what consecutive means. It means in order, numerical order. So if we have the question, the sum of 3 consecutive integers, so 3 numbers that are one right after the other, when you add them, because that's what sum means, it means you're going to get 96. All right, so let's go ahead and find those integers. So the first step, since we don't know where we're starting, we could start 2, 3, 4. Well, 2 plus 3 is 5 plus 4 is 9. Well, that's obviously not 96. So we don't know where we're starting. So we're going to make it a variable, like n. All right, and again, just remember consecutive just is moving on. But, too fast. Let's move on. Let's start right there. Okay, so when we know where we're starting, like if we were starting at 1 and we needed to say the next number, which would be 1 plus 1, which is 2, is going to give us the next thing. So if we move on from that, if I can do this a little slowly, the next number 3 is 2 away from 1, so it would be like adding 2. The next number 4 is like adding 3 to 1, because we're always comparing the next number in the sequence to where we started, okay? And since we know we're counting consecutive integers, wherever we start, the next number is just plus 1. The next number after that is plus 2, okay? So if the first number is n, the second number is n plus 1, and the third number is n plus 2. Because when we're dealing with consecutive integers, the next number is always being compared by the first number. All right? There we go. Okay. So number 2, add the differences of each integer for the number of integers you have. So I've now figured out that it's n plus 1, because that's the next number after n, plus n plus 2, because the third number is the second number after n, which is why we're adding 2. All right? Now, if they asked me for 4 consecutive integers, the next one would be n plus 3, because the fourth number is 3 more than the very first number, which in this case is n. Okay? So now, we're on step number 2, and we have all of them added together, where this is my first number, my second number, and my third number out of my 3 consecutive integers. Now we can combine like terms, and just remember that there's an invisible 1 in front of all of those n's, so that when I do combine like terms, I have 3 n's. Then I can combine the other terms, which is 1 and 2. 1 plus 2 is 3. And I know all of this equals 96, which means now I can solve using multi-step equations, or two-step equations from what I learned in the last lesson, lesson 1. Well, I'm going to have minus 3 on both sides. That's going to annihilate the 3, so that's gone. And then I'm going to divide by 3, which is going to annihilate the multiply by 3. But what I do on one side, I got to do to the other, and I'm going to get n equals 31. But remember, they are asking for what the integers are, so make sure you list them in your answer. So if n equals 31 and n is the first number, okay, but what is n? Well, n is 31, so it goes there, there, and there. So the first number is 31, the second number is 31 plus 1, and the third number is 31 plus 2, which means the numbers are 31, 32, and 33. And if you add them all up, you should get 96, which we do. Smiley face. Moving on. All right, so for consecutive, actually, we're going to stop that right there, and we're going to back it up, because I'm not ready to talk about that yet. All right, so for consecutive, even, or odd numbers, the first number is still a variable, n, but the difference between each number is 2 instead of 1 for regular consecutive integers. So remember in the last one, we were moving up by ones, but the thing is that evens and odds have a difference of 2 between them. Even odd numbers have a difference of 2, and we'll talk about that right now. So even numbers, you're counting by 2. So if I don't know which even number I'm starting at, n, the next number is going to be plus 2. The number after that's going to be plus 4, plus 6, plus 8. So again, we're counting by 2's. But you know what? It's the same thing for odd numbers. 1, 3, 5, 7, 9. If I don't know which odd number I'm starting with, the difference between the first odd number and the second odd number is still 2. All right? So make sure that you pay attention to that. Even though you might be doing even or odd, you're still doing a difference of 2. Okay, let's do example for problem. Find 2 consecutive even integers with the sum of 66. So since we're counting by 2's for both even and odds, we got to set it up like this. The first number is going to be an even number, right? Because we know it's even, but we don't know what it is, so we're going to make it n. But we know that the next even number from where we start is 2 more than where we started. So it's going to be n plus 2. Well, now let's go ahead and combine like terms. We have 2n's plus 2 equals 66, and solve for n. We're going to minus 2 on both sides. We're going to divide by 2 on both sides. We're going to get n equals 32. So if n equals 32, that's the first number. The second number is 32 plus 2. Well, 32 plus 2 is 34, because it's the next even number. 32 plus 34 is 66, and we're all done. All right, so, okay. So now that we've got that, the last thing you need to know about solving multi-step equations is that the distributive property can come out to play. So whenever you have parentheses that are being multiplied by a number outside of the parentheses, like my first example here that's been messing around, we have -3 times the quantity means things in parentheses, m minus 6 equals 4. So whenever you have this going on, you have to use a distributive property to get rid of that number outside of the parentheses first. All right? So we're going to go ahead and do that. We're going to distribute the -3 to the m and the 6, so I'm going to make it plus -6 because I'm going to add the opposite. So I have -3 times m plus -3 times -6 because I added the opposite. All right, I'm going to simplify a little. -3m plus 18, because -3 times -6 is positive 18, equals 4. Now I have what I had from the previous lesson, from lesson 1. Now I can take care of my low priority stuff first, which would be subtracting 18 on both sides. And again, the plus 18 on the left annihilates the minus 18 on the left. But again, if I minus 18 on the left, I have to minus 18 on the right. And I'm going to get -3m equals -14. I'm going to divide by -3. -14, and again, this -3 right here and -3 annihilate each other because they are opposites. Well, not that they're opposites, but multiplying by -3 and dividing by -3 are opposite operations which annihilate each other. All right, so m equals positive 14 over positive 3 because a -14 divided by a -3 is a positive fraction. All right, right. And you can leave your answer like that because I totally accept improper fractions. But if you want, you can convert it into a mixed number, which is 4 and 2/3, which is how it will be written in your book if you do your own corrections. But I will do my best to do the conversion for you. All right, one more example problem. We have 3 times the quantity x plus 12 minus x equals 8. So again, we're going to distribute. We're going to get 3x plus 3 times 12 minus x equals 8. We're going to simplify, which is 3x plus 36, because 3 times 12 is 36, minus x equals 8. And then I'm going to use the commutative property, once I add the opposite, to move the x's closer to each other. All right, so now I have 3x plus -x plus 36 equals 8. Now I'm going to, I did that using the commutative property. So now I'm going to combine like terms. 3x plus -1x, because remember there's invisible 1 there. Remember the invisible 1. So that gives me 2x plus 36 equals 8, minus 36 on both sides, because there's my table. And then the 30 plus 36 and the -36 annihilate each other, though I didn't show it. There it is, bye. And then we're going to divide by 2 on both sides to get -14. And you can always check by using PEMDAS and plugging your answer back into the variable and into that as well. Because remember, I had 2 variables. So I have 3 times -14 plus 12 minus -14. Because remember, whenever I replace a letter with a number, the number goes in parentheses. The whole number goes in parentheses. So if it's -14, -14 goes in the parentheses. All right, let's combine some like terms or simplify. So -14 plus 12 is -2 times 3 is -6. Add the opposite and we've got 8. -6 plus 14 equals 8, which works. All right, I'm done. Bye, guys.